Good morning, all of you. Welcome to Sri Jayendra Rank Zone. Today we are going to discuss preparation of colloids. In the previous session, we have done what are colloids and how many types of colloidal systems are there, and also types of colloids. Now we are going to discuss how to prepare colloids. Preparation of colloids by different methods. Very important. In this only all the experiments are present. So we are going to discuss all the experiments now. So please listen carefully. Yes. Now we'll start the class. So preparation of colloids. Yes. The colloids can be prepared by chemical methods, dispersion methods, and peptidization. So it can be prepared by the mainly three methods, mainly that is chemical methods, means by the means of oxidation, reduction, dipole decomposition, etc. Dispersion methods, and also peptidization. So all the three methods we are going to discuss now. It's very, very easy to understand. Next, chemical methods. The colloidal solutions are prepared by dipole decomposition reactions, oxidation, reduction, or hydrolysis. So we can prepare colloidal solution by using suitable reagents by the means of dipole decomposition reactions, oxidation, reduction, or hydrolysis. Hydrolysis means addition of water. The product formed aggregates. Aggregates means together forming so many particles. Aggregates like soap. In the soap, what happens? It forms an aggregate that is called associated colloid. So the product formed aggregates to give colloidal particles, to give particles of colloidal size. Aggregates means just like associated colloids, like micelle. Next, so let us see the double decomposition and oxidation reduction or hydrolysis. Coming to chemical methods, first example, arsenic oxide on reaction with hydrogen sulfide, it on double decomposition, undergoing double decomposition forms arsenic sulfide. Here, sulfide S2 minus, here S2 minus, that is nothing but here sulfur is in the place of oxygen and oxygen in the place of sulfur. So that is called double decomposition. So it forms arsenic sulfide salt along with water. This salt is called a colloidal solution. Next, sulfur dioxide plus H2S hydrogen sulfide on oxidation. Oxidation, here sulfur is undergoing reduction to form sulfur salt and hydrogen is undergoing oxidation to form water. So this is called oxidation or reduction. So sulfur is undergoing what? Reduction, because sulfur dioxide is undergoing reduction to form, because removal of oxygen takes place to form sulfur, whereas hydrogen sulfide is undergoing oxidation to form water. So I hope it is clear. So this is oxidation and reduction. Next example, gold chloride. This is AU, Cl3, gold chloride on reaction with acetaldehyde. Sorry, it is nothing but formaldehyde. It is not acetic acid, it is formaldehyde. So gold chloride on reaction with formaldehyde plus water, it forms under reduction, it forms gold along with acetic acid along with HCl. So this is the preparation of gold salt. Gold salt is prepared by taking gold chloride along with formaldehyde and water undergoing reduction process. Next, ferric chloride on hydrolysis. Ferric chloride means Fe plus C state. So ferric chloride on hydrolysis forms ferric hydroxide salt, that is colloidal solution, along with HCl. So all this salt is nothing but what? They are called as colloidal solution. So these are the examples of chemical methods. So colloidal solutions can be obtained by chemical methods, peptidization methods, and others. So let us see next, dispersion method. Bredig-Sark method. It is called what? Bredig-Sark method. It is also called as dispersion methods. Let us see what is dispersion method. So metal salts like gold salt. Here they'll ask the question based on this. What they'll ask means gold salt is obtained by which method? So Bredig-Sark method. So metal salts like gold salt are prepared by this method. That's why classification is important. Two gold electrodes are kept immersed in water, dispersion medium kept in an ice bath. So we need to take two gold electrodes. Electrode means one is cathode and there is anode, and are kept immersed in water. So two gold rods are kept immersed in water, dispersion medium, and gold is nothing but dispersed phase, kept in an ice bath. Ice bath means this water is covered with ice bath. An electric arc means as they are electrodes we are taking, so we need to connect them to a battery. An electric arc is stuck between the electrodes means what? These two electrodes are connected to a battery. When the two gold electrodes are connected to the battery, current is passed. And an electric arc is stuck between the electrodes means current is passed. The metal gets vaporized. So the gold electrode metal gets vaporized and condenses back into the medium to form colloidal solution. So it condenses and form to in the colloidal solution. And to make it more stable, a small amount of KOH is added to stabilize the salt. So a small amount of KOH is added to stabilize the salt. This is called as Bedik's arc method. So let us see the diagram of Bedik's arc method now. See here, these are the two gold rods, electrodes, metal electrodes, and these two are connected. So this is nothing but two gold electrodes. What are these two? These two are called metal electrodes. That is nothing but gold metal electrodes. And this is an electric arc is stuck between the two electrodes, and these metal electrodes are immersed in water, and this water is kept in ice bath. This is called ice bath. Then what happens when the electric arc is stuck between them? What happens? The gold metal vaporizes. The gold metal, what happens? It gets vaporizes and forms colloidal solution in water, colloidal salt in water. And why we are keeping it in ice bath? Because this colloidal solution is very hot. So as this colloidal solution is very hot because it vaporizes. So to make it cool, we have to keep ice bath. So this is called preparation of gold salt. So the gold salt will be prepared in water. So here the gold salt is formed. So this is called nothing but what? After electric arc is struck, it is called as gold salt. So this is gold salt. So two gold electrodes are kept in water, which is surrounded by an ice bath. Then an electric arc is stuck between the two electrodes. Then what happens? These electrodes gets vaporizes into form colloidal solution. Vaporizes to form these electrodes vaporizes to form colloidal solution. And as this colloidal solution is very hard, that's why it's kept in ice bath so that it gets condensed. It gets condensed. I hope it is clear. This is called Vedic arc method. From this method, we can prepare gold sol. How to prepare gold sol as we discussed right now. I hope it is clear. Next one. Second method is dispersion method that is called peptidization. So peptidization is the method of conversion of suspension size particles into colloidal size particles. Means the particles which are going to suspend. So that is nothing but suspension size, almost near to colloidal size particles we can prepare. So this is done by adding a small amount of electrolyte. So how a peptidation can be formed? It is formed by adding a small amount of electrolyte to the precipitate. So precipitate can be converted into colloidal solution. That is called peptidation. Simple words, what you can say, a precipitate can be converted can be converted into colloidal solution. It is nothing but peptidation. Peptidation is a method of conversion of suspension size particles to colloidal size particles. There is nothing but precipitate into colloidal cell. This is done by adding small amount of an electrolyte to the precipitate. If you add small amount of electrolyte to the precipitate, the electrolyte added is known as peptidizing agent, so that it can convert, that electrolyte can convert the precipitate, that is suspended particle, into colloidal sized particles. Example, ferric hydroxide is prepared by using this method. I hope it is clear. So this is called peptidization. By the addition of small amount of electrolyte, we can convert a precipitate into colloidal solution. This is called peptidization. So freshly prepared ferric hydroxide, FeOH taken thrice, is added to a dilute solution of ferric chloride. So if you add ferric hydroxide to ferric chloride, ferric hydroxide particles absorb ferric ions. So example of peptidization, ferric hydroxide particles absorb ferric ions from the solution to form positively charged colloidal particles. So the formation of colloidal particles is due to preferential adsorption of one of the component ion by the particles. So in peptidation method, the formation of colloidal particles, this statement is important. In peptidation method, the formation of colloidal particles is due to preferential adsorption of one of the component ion by the particles. So ferric hydroxide can absorb ferric ions from uh, ferric chloride solution. I hope it is clear. Next, purification of colloidal solutions. So we have now purification of colloidal solutions. So how to purify colloidal solution? Let us see now what are the different methods of colloidal solutions purification. So preparation of colloidal solution can be done by chemical methods as well as dispersion method as well as British salt method. Now we'll discuss what is how to purify colloidal solutions. Purification of colloidal solution, that is first one is dialysis. First one is what? Dialysis. Yes. So colloidal solution contains particles of suspension and particles of two solutions as impurities. So removal of these impurities is known as purification of colloidal solutions. So a colloidal solution contains particles of suspension as well as particles of two solutions. So to remove these, to remove these impurities, removal of these impurities is known as purification of salt. That is nothing but the methods of purification are first one is dialysis, very, very important. All the three methods are important: dialysis, electrodialysis, and ultrafiltration. Let us see what is dialysis now. So, first, let us see. Dialysis is a process of removing the particles of two solution from a colloidal solution. Dialysis is a process of removing the particles of two solution from the colloidal solution by means of diffusion to a patchment membrane, SPM, semi-permeable membrane or patchment membrane. So it is a process of removing the particles of two solution. So the membranes filter waste products from the blood. Actually, we can use it for blood also. So how to dialysis? For the purification of blood, we'll use dialysis. For the purification of blood, the persons who are suffering with the kidney problems, the person who is suffering with kidney related diseases, they can be undergoing dialysis. So dialysis is a process of removing the particles of two solution from a colloidal solution by the means of diffusion to a semi-patchment membrane, that is semi-patchment membrane or semi-permeable membrane, both are same. So SPM, a patchment bag, this is called a patchment bag. I hope it is clear. This dialysing membrane, that is nothing but what? It is called patchment bag containing colloidal solution. Here, these are the colloidal particles, salt particles, is kept immersed in water. It is kept immersed in water. The particles of two solution are driven away by the stream of water. So the particles of two solution are driven away by the stream of water, and remaining only colloidal solution will be there. So there is nothing but blood is also a colloidal solution to purify blood. So blood is a colloidal solution. Blood is a colloidal solution. And for the purification of blood, we'll use dialysis. For the purification of blood, we'll use dialysis. Let us see now. The membranes of filter waste products from your blood which are passed into the dialysate fluid. The used dialysate fluid is pumped out of the dialyzer and is filtered blood is passed back into your body through the second needle. So here what happens here? Blood is purified. Blood is a colloidal solution. The purification of blood. So pure blood is purified. Blood is purified by the means of dialysis. Here also this is called dialysing membrane. This dialysing membrane is called patchment bag. So this patchment bag containing colloidal solution, that is blood particles, along with some other impurities present in the kidney stones, etc., etc. So two solution particles is kept immersed in water. The particles of two solution are driven away by the stream of water, and then it is purified. Next, what happens? You just see here. So again, I'm showing that clearly. So a patchment bag containing colloidal solution is kept immersed in water. The particles of two solution are driven away by the stream of water here. so that the human blood is purified. So that is like that here also colloidal solution is purified. So this is first purification of colloidal solution from the two solution, that is called dialysis. Not only blood, we can say dialysis is a process in which we can purify the colloidal solution from two solutions. We can purify. So it is a process of removing the particles of two solution from a colloidal solution by the means of diffusion to a parchment membrane, SPM. I hope it is clear. So what is electrodialysis? Nothing but normal dialysis is a slow process. By applying electric field, the speed of dialysis can be increased so that purification can be done faster. So the purification of colloid is is done nowadays by using electrodialysis. By using electrodialysis. What is electrodialysis? By applying electric field, the speed of dialysis can be increased. Same process. So parchment membrane will be there. Colloidal solution particles will be taken in this membrane, and water will be, and this is kept in water. So by passing current, what happens? It speeds up the solution particle will be like this. Crystalloids will be like this. The crystalloids are nothing but what? Two solution particles. Here the crystalloids are nothing but what? Crystalloid is nothing but true solution particles. So two solution particles will be taken out, colloidal solution will be formed. So dialyzing membrane, water plus electrolyte, here cathode and here anode will be there. So this is called electrodialysis. I hope it is clear. Electrodialysis. So the dialysis carried out under the influence of electric field is called electrodialysis. The dialysis carried out under the influence of electric field is called as electrodialysis. What is dialysis? For the purification of colloids, we use the method called dialysis. For the purification of colloids, we will use the method called dialysis. Dialysis is a method where we can purify the colloidal solution from two solutions. I hope it is clear. Next. The dissolved ions diffuse faster through semi-permeable membrane and migrate towards oppositely charged electrodes. As we are passing electricity, the dissolved ions, that is, the dissolved ions crystalloids, diffuse faster through the SPM, semi-permeable membrane, and migrate towards oppositely charged electrode. So due to this, what happens? Dialysis is being done. Next method of purification is ultrafiltration. Colloidal solutions are purified by using an ultra-filter paper. It is more uh, modern method of purification. Colloidal solutions are purified by using an ultra-filter paper. The ultra-filter paper is the normal filter paper treated with colloidal solution to reduce the pore size. Very important point. So here what happens? The ultra-filter paper is the normal filter paper treated with colloidal solution to reduce the pore size. In these pores, the colloidal particles get stuck up. So the collodion is a 4% solution of nitrocellulose in a mixture of alcohol and ether. What is collodion? Collodion solution is a 4% solution. This point they can ask in the objective. What is collodion? Collodion is a 4% solution of nitrocellulose in a mixture of alcohol and ethers. So this is called collodion. It is different from colloidal solution. So the ultra filter paper is the normal filter paper treated with collodion solution. So if you take filter paper and treat it with collodion solution, it forms to reduce the pore size. Pores means here the colloidal size particles. I hope it is clear. Now let us see more about ultrafiltration. The ultrafilter paper allows only particles of two solution. It allows only particles of two solution to pass through it, but not the colloidal particles. So the process of ultrafiltration is very, very slow. External pressure is applied to increase the speed of the process. To increase the speed of the process, we have to apply external pressure. The colloidal particles on a ultrafilter are then mixed with dispersion media to get back to the colloid. The colloidal particles on ultrafilter are then mixed with dispersion media to get back the colloid. So here, external pressure is applied to increase the speed of the process, and what are the colloidal particles are obtained on a filter, they are mixed with dispersion media to get back the colloid. I hope it is clear. Next. This is the ultrafiltration raw material. Raw water will be taking screening, just diagram, sand filtration, microfiltration, 0.01 micron, ultrafiltration means more purification. And finally, dissolved salts will be left over here, and this ultrafiltered water will be coming like this. This is the method of ultrafiltration, three stages of filtration of water. Bias, organic macromolecules, colloidal bacteria, red blood cells, and then dissolved salts. I hope it is clear. Next. So this is the ultra filtration industry in unit in industry. So we can get ultra filtration water. So this is the ultra filtration unit. Next, properties of colloidal solution. So far we have done preparation of colloids. We have done purification of colloids. Next we have properties of colloidal solutions. So this chapter we are going to do this properties of colloidal solution now. So today's class we have discussed already preparation of colloidal solutions by chemical methods and other methods, physical methods. Next, we have purification of colloidal solution. Purification of colloidal solution is done mainly by three methods. One is dialysis, electric dialysis, ultrafiltration. Now we'll see properties of colloidal solutions. Simple it is: colgate properties, Tyndall effect, color, Brownian movement, electrophoresis, and electroosmosis. Now we are going to discuss about all these properties. What are colgate properties? Is nothing but this we have discussed in dilute solutions. That is nothing but what? When a non-volatile solid is dissolved in a solution, the the properties of the solution changes. That is called colligative properties. So the changing a change is observed in the solution. So what are those changes we are going to discuss now? So properties of colloidal solution, properties of colloidal solutions. We have colligative properties, Tyndall effect, color, Brownian movement, electrophoresis, electroosmosis. Let us see the different methods of colloidal solutions. Properties. First, colligative properties. The colloidal particles are relatively larger due to the aggregation of particles. The number of particles present in a colloidal solution. The colloidal particles, the colloidal particles are relatively larger due to aggregation of particles because they join together to form a giant molecule. So that is called aggregation. So usually they are relatively larger due to aggregation of particles. So the number of particles present in a colloidal solution is less compared to that in a true solution. So the number of particles present in a colloidal solution is less compared to that in a true solution. So the values of colligative properties of colloids are less than those of two solutions having same concentration. The values of colligative properties of colloids are less than those of two solutions having the same concentration. So the number of particles present in a colloidal solution is less compared to that in a two solution. So that's why. Let us see now. Tyndall effect. Very, very important. So I hope you understood colligative properties. Again, I'll explain. The colloidal particles are relatively larger due to aggregation of particles. The number of particles present in the colloidal solution is less compared to that in a true solution. This point is valid here. So it is less when compared to that in a two solution. So the values of colligative properties of all colloids are less than those of two solutions having same concentration. So what are the colligative properties we have? Elevation, boiling point. Second one, relative lowering of vapor pressure. Third one, depression in freezing point. Depression in freezing point. And fourth one, osmotic pressure. So these are the colligative properties. So the colligative properties, main important point is the colligative properties of colloids are less than that those of two solutions having same concentration. For example, if I tell you one molarity colloidal solution and one molarity true solution of any other of a some example you can take one molarity colloidal solution like gold salt and one molarity true solution like sugar solution. So the colgate property is always same concentration, two solutions having same. If you take two solution of gold also, even if you take two solution of gold again, I'll tell you, because we have to compare with this, the same solution. So two solution of gold salt, and here two solution of gold having same molarity, but the colligative properties are less of these colligative properties are less when compared to colligative properties of two gold solution. I hope it is clear. So see why it is happening, because the number of particles present in a colloidal solution, the number of particles present in a colloidal solution is less compared to that in a two solution, due to which what happens automatically the colligative properties also will be less. I hope it is clear. Next, Tyndall effect. Tyndall effect is a very important here. Tyndall effect. You'll get a question from this also usually. What is Tyndall effect? Tyndall effect is the scattering of light, simple it is, by the colloidal particles. Means for the colloidal particles, if you incident light on them, then lights get scattered in all the directions. The light gets scattered in all the directions. So this is nothing but Tyndall effect. Tyndall effect is the scattering of light by the colloidal particles. The intensity of scattered radiation is maximum at right angles to the incident light. The scattering of light illuminates the path of the light in colloidal medium. The bright cone of light is known as Tyndall cone. This is observed in Tyndall effect. Let us see the diagram of Tyndall effect. See here, colloidal particles are kept here. This is called light source. From light source, if you incident light on the colloidal solution, that is soil tin, what happens here? If you see by the means of powerful microscope, you can see the scattering of light takes place. Scattering of light takes place in all the different directions. If you view under microscope also, light gets scattered in all the directions. This is nothing but due to Tyndall effect. And Tyndall effect is nothing but what? The reflection of light. It is not reflection of light, dispersion of scattering of light. The Tyndall effect is due to scattering of light. Scattering of light is taking place. Scattering means it is moving in all the directions like this. So scattering of light takes place in Tyndall effect. So the Tyndall effect is due to scattering of light. So, and Tyndall effect is observed only, this is very important. Tyndall effect is observed only, again I'm writing here, Tyndall effect. This point you please note down in your classwork. Tyndall effect is observed only under two conditions. Under two conditions. First condition, writing it here, please note it down. If the diameter of the dispersed, if the diameter of the dispersed diameter of the dispersed particle is not dispersed particle is not much smaller than the is not much smaller than the wavelength of lambda of light used. Lambda of light used is the first condition. Second condition, the refractive indices. The refractive indices. These 2 points, please note it down. The refractive indices of the dispersed phase. Of the dispersed phase and dispersion medium. And dispersion medium, very important. The refractive indices of dispersion phase and dispersion medium. Dispersion medium differ greatly in magnitude. Differ greatly in magnitude. Means they should have a lot of difference between the refractive indices of the dispersed phase particles as well as dispersion medium. So here the dispersion medium is light and dispersion medium is water. Dispersed phase particle is the colloidal solution. So a simple experiment is nothing but what? When a certain light of wavelength, when the light of certain wavelength is incident on the colloidal solution, it gets dispersed. The light gets scattered in all the directions. The light gets scattered in all the directions, forming a cone called Tyndall cone. So this is called Tyndall effect. Simple scattering of light particles, scattering of light by the means of colloidal particles. It is nothing but Tyndall effect. And Tyndall effect is observed only under two conditions. First one, if the diameter of the dispersed particle is not much smaller than the wavelength of light used. It is not much smaller. The diameter of the dispersed particle is not much smaller than the wavelength of light used. Second one, the refractive indices of the dispersed phase and the dispersion medium differ greatly in magnitude. The refractive indices of the dispersed phase and dispersion medium should have lot of difference. That is differ greatly in magnitude. So this is called Tyndall effect. I hope it is clear. Please note down these 2 points. And next, this is the effects of properties of colloids. First property, Tyndall effect. Second property, illustrations for Tyndall effect. You can see here, this is the Tyndall effect. This is the bright cone. Light is incidenting on the water solution containing colloidal particles. So a bright cone is formed like this. So this is called bright cone, bright light. So while light gets scattered by the means of dust particles in air. So dust particles in air are also nothing but colloidal particles. They are in the colloidal size. So this is nothing but during winter you will observe this. You will observe this during winter. So this is called Tyndall effect. Tyndall effect. I hope it is clear. Next, ultra microscope. When we observe the colloidal solution at right angles to the incident light, if you observe by using ultra microscope, if you observe at right angle here 90 degrees, by the means of microscope, we can see a particle which was invisible under a normal microscope. This arrangement is known as ultra microscope. So we can see an invisible particle under a normal microscope. So under a normal microscope, that particle is not visible. Whereas if you see from ultra microscope, that particle is visible. So this is nothing but ultra microscope. So this is the ultra microscope which you use in the labs. Color of colloidal particles. The color of colloidal particles is due to scattering of light. It is nothing but what? It is due to scattering of light. Depending on the wavelength of the scattered radiation, colloidal solutions have different colors. Depending upon the wavelength of scattered radiation, that is light, colloidal solutions have different colors. The wavelength of the scattered radiation depends on the size of colloidal particles. So the wavelength, as I told you, the wavelength of the scattered radiation depends on size of colloidal particles. And naturally, the size of colloidal particles should be greater than the wavelength of light. So you observe this gold sol is red in color. As the size of the particles increases, it appears purple, blue, and also golden color. So gold sol usually is red in color. As the size of the particles increases, it appears purple, blue, and also golden color. That is due to scattering of radiation light. I hope it is clear. Next. So this is called color of colloidal particles. Next, we have Brownian movement. Very, very important. What is Brownian movement? What is Brownian movement? The zigzag or random movement of colloidal particles. The zigzag or random movement of colloidal particles is known as Brownian movement. This was observed by Robert Brown. This is due to the collision between the colloidal particles with the molecules of dispersion medium. Why this Brownian movement is observed? If you see the colloidal particles under the powerful microscope, you'll notice that in the colloidal movement, particles will move. A zigzag or random movement of colloidal particles takes place, which is called as, see, like this zigzag movement will be taking place, which is called as Brownian movement. It was observed by Robert Brown. This is due to why the zigzag movement takes place. This is due to the collision between the colloidal particles with the molecules of dispersion medium. The collision due to the colloidal particles with the molecules of dispersion medium. So the dispersed phase particles and dispersion medium gets collided with each other. So due to which water gets collided with each other, that is collision. This is nothing but Brownian movement. I hope it is clear. Next, let us discuss some questions. So what we have done so far, we'll discuss right now. So here in this class, we have done preparation of colloids as well as purification of colloids as well as properties of colloids. Very, very simple. Now let us discuss certain important colloid questions based on colloids so far we have done, because in the previous session also we have discussed few questions. Now we'll discuss more questions in this, some important questions based on this. So question number one, the dispersed phase, I'm writing it here, please note it down. The dispersed phase comma dispersion media comma and the nature of colloidal solution and the nature of colloidal solution of gold salt respectively are. The dispersed phase, dispersion medium, and the nature of colloidal solution of gold salt respectively are. So answer I'm writing directly here. No option I'm writing here directly. I'm writing the answer. Please note it down. So gold salt is solid. Dispersed phase is solid. Dispersion medium is liquid. Dispersion medium is liquid, and type of colloidal solution is lyophobic colloidal solution. Lyophobic means solvent hating. Lyophobic. So very, very important. Solid, liquid, and lyophobic. So the dispersed phase, dispersion medium, and the nature of colloidal solution of gold salt respectively are solid, liquid, and lyophobic. So gold salt is in gold salt, dispersed phase particle is solid, that is gold, and dispersion medium is liquid, that is water, and it is nature of the solution is lyophobic. Nature of the colloidal solution is what? Lyophobic salts, that is nothing but what? Solvent hating. Means gold particles are not attracted towards water. So that is nothing but solvent hating. I hope it is clear. Next question. Question number 2. Let us discuss some important questions I want to discuss. That's why we are doing it now. The simplest way to check whether a system is colloidal or not. So answer for this is, what is the answer now? So it is nothing but Tyndall effect. If you check, if you check the Tyndall effect, means if you incident light on the system, the scattering of light takes place, then that is nothing but 100% it is a colloidal system. I hope it is clear. Next question. During the cleaning action of soap, question number 3. During the cleaning action of soap, dash part of soap dissolves in the dirt. This question is very important, that's why I'm discussing. Dissolves in the dirt means it will mix up with the dirt. Dissolves in the dirt and encapsulates to form and encapsulates to form micelle. And encapsulate means aggregate. Encapsulate to form micelle. So in soap we have two parts. One is hydrophobic and this hydrophilic. One is attracted towards water and this attract towards not attracting towards water. So it contains what is soap here, what are soap here, just answer we are discussing now. Sodium salt of fatty acids. So sodium salt of fatty acids consisting of soap. So sodium salt of fatty acids. In that we have two parts. One is hydrophobic and there is hydrophilic. So sodium part, that is sodium ion, is hydrophilic. Sodium ion is hydrophilic part. That is a positive one, hydrophilic, because these are polar. And RCO minus. RCO minus is hydrophobic part. It's a giant molecule, hydrophobic. So here the answer is during the cleaning action of soap, dash part of the soap dissolves in dirt. So that is the hydrophobic part. So I'm writing here. Again, spelling is mistake here. Just again I'm writing hydrophobic part. Hydrophobic part. Hydrophobic means solvent hating. So hydrophobic, that is water hating. Hydrophobic part of soap dissolves in the dirt and encapsulates to form micelle. I hope it is clear. So during the cleaning action of soap, the hydrophobic part of soap dissolves in the dirt and encapsulates to form micelles. Next question. Next question. Just want to write. In colloidal state, the particle size ranges from in a colloidal state. Question number 4. In a colloidal state, the particle size ranges from. So already you know the particle size of colloidal state. The particle size is 1 nanometer to 100 nanometers. So here we can also take it as 10 angstroms to 1000 angstroms, because since 1 nanometer is equal to 10 angstroms, so answer can be this or this, both are same. So the colloidal state of the particle size ranges from 1 nanometer to 100 nanometers or 10 angstroms to 1000 angstroms. I hope it is clear. Next question. When a colloidal solution is observed under a microscope, we can see. Next question. Question number 5. When a colloidal solution, is observed in a under an ultra microscope, comma, we can see dash dash. So answer I'm writing here directly. Light scattered by colloidal particles. So this is the only answer we have. So what is the answer? Light scattered by colloidal particles, that is due to Tyndall effect. Next question. The diffusion of particles in colloids. The diffusion of particles in colloids is. So for this answer, I'm directly writing because they have given four statements. Statement number one, rapid than in true solution, slower than in suspension, slower than in true solution, equal as in true solution. So the answer for this is slower than in true solution. Slower than in a true solution. So colloidal solution movement is very, very slow when compared. That's why we have colligative properties is also less. I hope it is clear. Next question. Question number 7. Which of the following which of the following which of the following which of the following is a non-electrolyte colloidal solution? First option we have starch. Second option we have silver chloride solution. Third option we have arsenic sulfide, arsenic sulfide salt, and fourth option we have antimony sulfide salt. So answer is starch because here this is non-metal. Starch is nothing but what? C12H22O11. So nothing but sucrose or C6H10. Sorry. Starch is nothing but C6H10O5 taken N types. So this is nothing but starch. So in this all non-metals are there. So definitely it should be a non-electrolyte. If metal is there, it can be electrolyte. Next question. Question number 9. In substance which forms micellin in the solution contains. So first option they have given first option carboxyl group. Second option alkyl group. Third option water insoluble long hydrocarbon groups. Long hydro water insoluble long hydrocarbon groups and water soluble polar groups. Polar means water soluble. Fourth option water soluble hydrocarbon group. Water soluble hydrocarbon group and water insoluble polar group. Water insoluble water insoluble polar group. So first one carboxyl group, second one alkyl group, third one water insoluble long hydrocarbon groups and water soluble polar groups, and fourth one water soluble hydrocarbon group and water insoluble polar groups. Already we know hydrocarbons are soluble in are insoluble in water, and this water insoluble long hydrocarbon groups only attacks the that part and forms micelle. So this is called a substance which forms micelle in the solution contains water insoluble long hydrocarbon groups and water soluble polar groups, because it is nothing but C17H35 CO minus Na plus. So this is called water soluble polar group and water insoluble long hydrocarbon group which contains carboxyl. So I hope it is clear. Next, question number 10. So all these questions are very important. That's why I want to discuss this. Which of the following, very, very important question. This question is most important. Which one of the following, which one of the following constitutes, which one of the following constitutes irreversible colloidal system? Irreversible colloidal system with water as dispersion medium. With water as dispersion medium. With water as dispersion medium. Option 1, clay. Option 2, platinum. Option 3, ferric hydroxide. And option 4, all of these. So answer is, which one of the following constitutes irreversible colloidal system with water as dispersion medium? Clay is also water as dispersion medium, platinum, ferric hydroxide. So answer is all of these. So all these questions you have to note down in your classwork. Next question. Next question. Butter is a colloid. Is a colloid. It is formed when? The question is, it is formed when? Directly I'm adding the answer. Options also I'll discuss. First option, fat is dispersed in solid casein. Fat globules are dispersed in water. Water dispersed in fat. Water dispersed in fat. That is liquid in solid. Water dispersed in fat. This is liquid in solid. Dispersed in solid. Dispersed because fats are solids. Dispersed in solid. I hope this is the answer. Water dispersed in fat is nothing but water. Next question. Question number 13. When dispersed phase is solid and dispersion medium is gas, dispersion medium is gas, comma, the colloidal system is the colloidal system is first option smoke, second option clouds, third option emulsions, fourth option milk. So we take smoke, dust particles present in air. So dust particles are solids and air is dispersion medium, that is gas. So answer is first option. Because if you take clouds, liquid droplets. Liquids means liquid in gas. Emulsion is solid in liquid. And here solid in liquid, milk. So answer is only smoke. I hope it is clear. Next question. Question number 14. Next question. The kind of colloid that does not exist is first one solid in gas, second one gas in solid, which is gas in solid, third one solid in solid, and fourth one gas in gas. So very easy question but typical. So answer is gas in gas. Gas in gas colloidal solution cannot exist. Gas in gas colloidal solution is cannot exist. Next question. Question number 15. So how will get questions? I'm just discussing. I just want to discuss. That's why giving all this thing. Which are the following? Next question. Crystalloid and colloid can be distinguished by, because we have seen the crystalloids in dialysis. So crystalloid and colloid can be distinguished by. Very important question. Concept based. Distinguished by. So directly I'm writing answer. So by diffusion through membrane. Diffusion through membrane. Answer. So answer is this, diffusion through membrane, because crystalloids can diffuse, but colloids cannot diffuse. Colloids cannot diffuse to SPM. That's why human blood is colloidal solution. It will not diffuse to SPM, but all the crystalloids, what are the stones present in the kidneys or any other infection, so they can be diffused out. So colloids cannot diffuse to SPM. So crystalloids and colloids can be distinguished by diffusion to membrane, that is semi-permeable membrane or parchment paper. I hope it is clear. So these are the important questions which I want to discuss for today's session. And next session we'll do other topics in this chapter. I hope it is clear. Yes. So in this session we are done. preparation, purification, and properties of colloids. I hope it is clear and some questions based on it. So I'm stopping this class. Thank you.